Hi guys, how lovely to see you. So MGC is here, my name is still Alexey, and today is our second video of our Spring AOP journey. So in this video we are going to cover all this magic behind the Spring AOP and understand how it works under the hood. In this video we will refer the content of our first video, so I strongly encourage you to take a look at our first video so you will be in the context and you will understand everything what is going on here. From what we will start? We will start from the documentation, and in Spring AOP documentation you can see that Spring is powered by AspectJ point cuts. So in your when you're writing the aspects, you can use the AspectJ annotation style to write your aspects. So why Spring only powered by AspectJ, and why you could use the AspectJ annotation and not the AspectJ itself? So let's try to sort this out. To understand this, let's try to write the aspect using AspectJ. So for this we will create a separate project, Maven project. We will definitely include the dependencies to the AspectJ. We also will need the AspectJ viewer, and the essential part here is the Maven plugin, which will use the AspectJ compiler. So here we use the compile goal and test compile. Okay, let's take a look at the example. So just as usual, just as we had in our previous video, we have the congratulation service with two methods, both the congratulate method and the second one with two arguments invoke the first method from the same class and also print some messages into the console. So how we, with the AspectJ, how we write our aspect for this class? So for this, we have to create the separate class. In this case, we need the not the class like keyword in Java, but the aspect keyword. So it's not like Java keyword, it's only applicable for the AspectJ. So here we define the aspect. And with this aspect, we firstly, just as like in usual aspect when we use the annotation style, we need to define the point cut. In our case, it will be the execution of the all public methods with any return type in the congratulation service, any methods with any arguments. And also we need to specify the advice for our aspect. So it will return the object, it will also accept the object. It will be around advice, which means that we will control the execution flow inside our aspect. And this advice will be used, will use the point cut which we defined in previous lines. So here exactly the same body, and here just as usual we again invoke the proceed method, which means that before the invocation of our original method we do some logic, then we execute the expected logic, and then we do something when we do our main logic. So here, as you could see, my IDE even do not recognize this like a valid Java code and not a valid code at all. So it's complains that something wrong here, but don't worry, this code is working. So and here we have the main application, no Spring, nothing, only the AspectJ here. We just create our service just as usual and invoke the congratulate methods. So let's take a look at the output of this execution. Here in the console log, you could see that before the first invocation of the congratulate method, we see that we have some output from the login aspect. So we start execution, it's like the same here, so person arguments and the method itself. And then when we execute our second method, where we have the execution of another method from the expected method, you could see the two logs in the console. So firstly we execute the congratulate method with two arguments, Alexey and give the car, and then we started execution of the first method with only one argument. So with the AspectJ we do not have the problem which we have when we using just the plain Spring AOP. We have correct login here, and we have the method aspected in proper way. So how this work and why this work, you could understand this if you take a look at the decompiled class of the congratulation service. If you take a look at the compiled classes and take a look at the congratulation service, so here you could see that no more like system out println, and here you could find the logic which were inserted by the AspectJ, and here you could find that we indeed use the login aspect, and we just delegate the invocation to this login aspect, and our login aspect is the same as we have in our source class. So it's somehow compiled to the class and to the Java class, and here you could find the same annotations which we use when we use the Spring AOP. So here the answer why the aspects here works in a proper way is that when you use the AspectJ, you could use the compile time viewing. In that case, your source class will be definitely changed, and that's why the aspect logic will be inserted in two methods. So why do not use this when we use the Spring AOP? So to be honest, the Spring also works with the AspectJ. It has very good integration with it, and if you would like, you could definitely use the AspectJ and benefit from the using of the power of the AspectJ, and also use the capabilities of the Spring framework. And also I need to mention that AspectJ is more powerful than the Spring AOP, and it supports more point cuts, it supports more comprehensive advices, and so on and so forth. So the reason why not to use the AspectJ in the all the Spring AOP classes is the requirements to using the special compiler when you use the AspectJ. So if you use the compile time viewing, you have to use the AspectJ compiler to do all this magic and enhance and transform your source classes so that you will get all this aspect logic. In counterpart, you could use the load time viewing when you on the your class load time, your class will be changed and you will also have all this aspect logic. But in many cases, you cannot use the separate compiler, and it's not handy for you, or maybe it's just hard for you, or maybe you completely could not do this for some reason. Who knows? So in that case, it's where the Spring AOP comes into play, and it's just uses the AspectJ annotation, but all those aspect magic in the a bit different way. So let's take a look how the Spring AOP do this work. With the Spring AOP, we have almost the same setup here. So in the Cglib package, we have the class congratulation service with log method annotation, which marks that this method should be aspected and some additional logic should be added to it. The same for the second method. And we have also JDK proxy package. And here the only difference here is that we have the congratulation service as the interface, and here we have the implementation of this interface and the same methods with the same annotations. So just an example. Let's, for example, execute the Cglib package example, and here you could see that just as usual in the Spring AOP, we have the log message before the first invocation, finish the first invocation, and only one log message for the second method invocation, which means that invocation of the method in the same object is not aspected when you use the Spring AOP. Okay, let's try to sort this out and understand how it's works. So in Spring Boot, we definitely have some auto configuration for our AOP, and here the AOP auto configuration, and this is the configuration class auto configuration. And here we have some nested classes which configures for us AspectJ after proxy configuration. So here we could see the conditional on property, and if you're using in the properties the Spring AOP.proxy target class property with the value false, in that case this configuration will be applied, and if you have the value true and much if missing, which means that if you do not specify this property, this configuration will be applied. Both those configurations are mostly exactly the same, with only difference is the enable AspectJ proxy target class attribute with the value false and true. So let's take a look at this annotation. So this annotation is working with the import annotation. So on our channel, we already have the video where we explain all the import annotation and a lot of other special components in the Spring. So if you are interested, make sure you check the link in the description and on the tip at the up of the screen. So let's continue. So in import here we have the AspectJ after proxy register, which do the magic for us. So this class is the import bin definition register, which have the register bin definitions method. And here in this method you get the bin definition registry where you could find whatever bins you want. So in our case we do the register of AspectJ annotation after proxy creator if necessary. So what we have here, so here we have the logic which adds the annotation aware AspectJ after proxy creator to our registry. Let's quickly take a look here. What do we have? So if our registry already contains the after proxy creator bin name, so we do some special logic which tries to understand whether the current after proxy creator bin name have the like bigger priority, and if so, we like set the specific class name. So in general, when you use this Spring AOP, you have several classes which could create the proxies for you, and those classes have the priority. So for example, the AspectJ is the class with the biggest priority, because in some cases you could, for example, do not have the dependency to the AspectJ, and you could still use the Spring AOP, but not with the annotations from the AspectJ. So in that case, you could enable just the proxy creator with the lowest priority, which just could do less work. And we create the bin definition with this class and just register this to our bin definition registry. So let's take a look what is the annotation aware AspectJ after proxy creator. So if you take a look at the hierarchy of this class, you will see that this annotation aware AspectJ after proxy creator is first of all the proxy config. So we will take a look at this object a bit later. It's also the bin postprocessor. So bin postprocessor in the Spring, just a quick explanation. So this is the special bin in the Spring which is being instantiated really earlier. And this bin is controlling the creation of your bin. So it has two methods, one for adjusting your bin before the initialization, and another for adjusting your bin after the initialization. So we will take a look at it a bit later. And also this class is ordered. Okay, let's first of all take a look at the proxy config. So proxy config, this class, what do we have here? So we have the attribute proxy target class. So this was the attribute of our enable annotation. And here you could see that when we register this bin into the context, we also specified the proxy target class with this in this proxy config. So we take a look a bit, we try to understand what is the proxy target class attribute a bit later. Also some additional configuration of your proxy. So this configuration proxy creator class is the proxy configuration. So another thing that worth to be mentioned, that this is the bin postprocessor, and as the bin postprocessor, this class has the method postprocess after initialization here. So what we do, so this method is being called when the initialization logic on your bin is being invoked, and then the further logic which should be applied to your bin is being delegated to this postprocess after initialization method. So what do we have here? So we try to retrieve our cache key, and if we do not have early proxy reference for this bin, we try to wrap it if necessary. What is the wrap if necessary method? What do we do here? So here we have our bin, which is most likely not the proxy at this time, the bin name and cache key. So here, if this bin is already advised, if we already applied all the proxies to this bin, we just return the proxy at bin, nothing to do. Then we check if this infrastructure class, so what does it mean that is infrastructure class? We check if this the advice, if this the point cut advisor or infrastructure bin. So all those bins should not be eligible for the proxy creation. So in our case, we we definitely skip this. And this method also have the override in our AspectJ annotation aware AspectJ after proxy creator, which additionally uses the AspectJ advisor factory to check whether this bin class is aspect. So what is this check? So this check, if we have the annotation aspect annotation on this class, then we also should not like use this bin. It shouldn't be eligible for proxying. Okay, so isInfrastructure class, it is our first check. Then also we have the should skip check. What do we have here? So here we check if the original instance, I actually cannot say what this is actually do, but what we need to check here is again the overriding of those should skip method in the AspectJ aware advisor after proxy creator. So here we have defined candidate advisors, and for those advisors we check whether this advisor is AspectJ point cut advisor, and if so, we again should skip this class. It should also not be eligible for proxying. So what is the find candidate advisors? So we have the advisor retriever helper with the find advisor methods. So what do we have here? So here we have the bin factory reference, and from this bin factory we try to retrieve the names of all advisor bins. So advisor bins in most cases is the point cut advisor. So here you could see the point cut advisor, and as you remember from our previous video, that point cut advisor is the main component of the Spring AOP, which defines which point cut you should use and which advice you should apply to this point cut. So we like get all those names, and then we instantiate all those, we get those bins, and all those advisors is also like the cached, and we should not apply any aspect logic to our advisors. So here you could see that during this like wrap if necessary method, during the proxy creation, we like instantiate immediately all the advisor bins. And from the previous video, I've mentioned that in some cases you could use instead of, let me show you, instead of the point cut advisor, you could use the default bin factory point cut advisor, and in that case you do not specify the advice bin itself, you specify only the name. And so here could like save you if, for example, you need to instantiate your advice before like applying all the proxies, and in this case it won't be instantiated because it will be like retrieved on demand from the bin factory. Okay, just like a quick recap, let's go back to our method. So we instantiated all the advisors, and we check that if our bin is advisor, we should skip it. Okay, just we add this to the cache and like do nothing with our bin. So next step is get the advice and advisors for our bin. Okay, let's try to understand what this method do. Again, we have the abstract method. So here we try to find all the eligible advisors for our bin class. So how do we do this? We find all the advisors, so we already know what this method do. So it retrieves all the advisors bins from the context. Then we try to find which bins we could apply. So here we basically do this by checking the can apply. So here, as you already know, so advisors, is it introduction advisor, is it point cut advisor, which you know, and if it's point cut, you check whether it can be applied. How we check this? We get the class filter from our point cut and match it with our target, with our bin class. We also find the method matcher, and if we have at least one method from this class, we also like have the bin which is eligible for applying the proxy logic. So can apply, we already understand. So here we get all the eligible advisors, then we extend them if it's necessary. So some subclasses could extend this method, override this method if necessary, and if we have any eligible advisors, we sort them. So here the place where all those ordering logic applied, and that means that you could use the ordered annotation, order interface, and so on and so forth. And after this, we like return the eligible advisors. So if this advisors is not empty, then we like get the array of those advisors. So if we have interceptors, then we will need to create the proxy for our bin. So let's take a look how we create the proxy. So if we have this proxy, it's again goes to the cache, and we, instead of the original bin, we return its proxy. If we do not have any interceptors, then we do nothing with the bin and just return it, but mark this bin in the cache as bin which is not cached bin. Okay, create the proxy. Let's try to understand what's going on here. So here, as you could see, we have the proxy factory. So you should remember this class from our first video, because we use this in our tests to create the proxy. So Spring use the same class. So copy from here the method which accepts the proxy config. So we copy all the configuration which we have on our proxy creator bin to this proxy factory. So if here's the place where we use our proxy target class. So how do we use? So if we need to use proxy target class, we'll specify the interfaces to our proxy factory. If we do not need to use this, we also try to evaluate the interfaces, but we specify that proxy target class, we should proxy target class, not the interfaces. Okay, advisors build advisors. It's the place where we specify all the specific interceptors, and those interceptors is being built to be an array of advisor. Specify to our proxy factory all those advisors. Set the target source. Target source here is the let me again quickly show. So singleton target source is just a wrapper on our bin. So our target will be our bin itself, the bin itself. Then customize proxy factory is necessary. So you could override this in subclasses. Set frozen, pre-filter it, class loader. So we retrieve the class loader which will be used to load those class, to build the proxy of those class. And then we ask the proxy factory to create a proxy for us. So let's take a look how we create the proxy. Okay, create our proxy and get proxy. So for our proxy, we have only one implementation. So we have the only one implementation of the proxy factory is the default our proxy factory. And here we have the logic which is being applied to our to decide which proxy we need to create. So here the decision is based on the config. So if the config says that we should proxy target class, if we would like to proxy target class and we have no interfaces in our class, we will create the GDK, we will create the Cglib AOP proxy. In all other cases, if our target class is the interface, or we should not proxy the target class, we will create the GDK dynamic proxy. So let's start from the GDK dynamic AOP proxy. What do we have here? So here we have the get proxy method, which uses the proxy class from the GDK itself. So this is the package Java lang reflect proxy. And we create a new proxy instance using the proxy interfaces, class loader, and this. So last argument is the invocation handler, and our current class is the invocation handler. Okay, before we try to understand this, let's take a look at what do we need to create the GDK dynamic proxy. So in our directory we have the GDK proxy package, and here for the in application YAML we have the config Spring AOP proxy target class set to false, which means that if it's possible we should use the GDK proxy. And here we have the interface, we have the bin which implements this interface. Thus, when we ask for the bin with this interface, we should get the GDK proxy. Let's check this. So let's run this in the debug. And here you could see that our service is the proxy class. So we have a lot of things here, and it's not like the congratulation service itself. So let's take a look how this is being created. So first of all, we could take a look at the decompiled class. So if we take a look at this class, you could see that our proxy extends the proxy, which is the GTK class. So here just again Java lang reflect proxy. And we have implements the congratulation service. It's our service. That means that we have two methods, congratulate with one argument and two arguments. And for all those methods, we invoke the invoke method of the method invocation handler field in this class. Okay, let's get back to the GTK dynamic after proxy and try to take a look at the invocation handler. So invocation handler is the class which has only one method, invoke. So in our case, let's find this invoke method. So here, what do we do here? So we if we invoke the equals method, hash code to string and so on, we do apply some special logic in this invocation handler, but at the end of this method, so we have the following. So first of all, from our advised, so this is our proxy advised support, it's our proxy configuration, we get the interceptors, we get all the advice objects which is applicable for this particular method. So here we have this chain of those interceptors. If it's empty, we do nothing, we just invoke join point, we just invoke the method on our target. So let's quickly take a look how do we do this. It's just the method invoke with our target object. So it's our bin, not the proxy bin, it's our congratulation service as is. And if we have something, we have some interceptors for it, we create the reflective method invocation and just execute the proceed method on it. So let's take a look at this class and its proceed method. So in the proceed method, we have the index of the current interceptor, and if we reached the last interceptor, we do just invoke join point. So here we just again invoke those method on our target. So we just invoke the target method on the congratulation service itself. And if we do not reach the limit, we at some interceptor here, we just, in case of the dynamic interceptor, which applies only for several methods in the class, we try to understand whether this method match this point cut for a particular method. If so, we invoke this interceptor. If not, we just skip it and invoke again proceed, which just increment our index. And if it's not the dynamic method matcher, not the dynamic interceptor, we just apply those interceptor. We just invoke it. We just invoke on this interceptor. So to understand this a bit better, let's again run in the debug our GTK proxy. So here again our service. Just as you already know, we have the H with the invocation handler. This invocation handler is, in our case, it's GTK dynamic AOP proxy. So here we have the advised, although this invocation handler works with the advised. So in this advised, we have the advisors. So this is the list of our interceptors. In our case, we have only two interceptors. First is the expose invocation interceptor. It's this interceptor is always added by the Spring. And the second interceptor is our logging aspect. So it's instantiation model aware point cut advisor impl. And here you could see that log method execution we have here. And this is AspectJ advice method is the log method execution on the class, not the root, on our class with the aspect class. So that means that when we execute the congratulate method on our object, it firstly goes through all those two interceptors, and finally it gets from the target source, gets our congratulation service impl the object, which is not changed, which has only the system out println in its method, and just invocate its methods. So again, if it's not really understandable, I also wrote a diagram for you. So here you could see that. So we have the proxy class, which is our some proxy class which implements the congratulation service interface. It has the invocation handler, and when you invoke the congratulate method on DOS proxy, you goes to the invocation handler. This invocation handler firstly invokes the expose invocation interceptor. This interceptor we don't care what it do. It just like invokes the proceed on the object which it has, and this proceed goes to the next interceptor in the chain. In our case is the login aspect. So this login aspect just do the log info that we start the execution. It also invokes the proceed. So in our aspect we always invoke the proceed, and this finally goes to our congratulation service impl, which executes the congratulate service with 2 arguments. It's on this object without any like changing the code of this service, without having any magic in it. It just invokes the congratulate method with 1 argument, and it just goes and prints something that we have in congratulate. And when it returns again to the logic aspects first, then it invokes the finish. After that, it's like again returns to the expose invocation interceptor, and then returns the result from our proxy itself. So I hope now it's a bit clear how the JDK proxy works, and let's go back to our proxy factory and quickly take a look at the Cglib proxy. So basically this is mostly exactly the same concept how we create the proxy, but just use not the proxy class from the Java JDK, but use the Cglib. Let's again take a look how we do this. Get proxy method. So here at some moment we create the enhancer. So this class is the Cglib proxy package. So Spring just get this from the Cglib library, and here we use this enhancer to create the proxy for us. So we specify the superclass. So in this case, if for example we do not have the interfaces on our bin, or we specified like explicitly that we would like to proxy target class, we specify the superclass which we would like to extend. We, if needed, specify the interfaces, naming policy, strategy. We get the callbacks. So in Cglib, all the advice chain calls is called the callback. So we get the list of those callbacks and specify them. So types of those callbacks, and finally create the proxy. Again, with these callbacks, during construction and so on and so forth. Again, not too much details. Let's take a look how the class will be looked when we use the JDK proxy. So here, the case when we do not have interfaces, thus we just cannot use the JDK proxy, and we have to use the Cglib. So here service is the enhanced by Spring Cglib class, and here we have some callbacks, and the interesting thing here is the latest callback is the dynamic advised interceptor. And again, we have the proxy factory, which is advised, and this advised you should already know, because this the object which have the advisors. It's our 2 interceptors, which you already know, and finally the target source with the congratulation service as is, without like any magic in it, just the class which is being created. So now I think it's a bit clear about how the Cglib and JDK dynamic proxy works, and what the difference from it, and how those classes is being created. Okay, that was all for this video for today, and I hope now you understand better what's the difference between the Cglib proxy and JDK dynamic proxy, how to use them, how they work under the hood. And now, like, the main inception of mine is that now you should not be afraid to use the Spring AOP, and it's you understand the internals of it, and you could do this properly. You could avoid all the common mistakes, and if you miss something, or you need to understand something, you should know where you could find it. In our next video, we will take a look at the examples of Spring AOP from the different libraries and the Spring itself. So do not forget to subscribe to our channel to do not miss this video also, and like this video if you like the content of it and you enjoyed or learned something new. Okay, see you later.